Welcome to our channel Circuits Analytica. In this tutorial, we will do nodal analysis of a network to find voltage drop across 10 ampere current source. So here the network consists of a current source whose value is denoted as -2 ampere. So let us redraw the circuit after reversing the polarity of this -2 ampere current source. Mark various nodes as node P, Q, R and S. Mark currents associated with nodes as shown in the diagram. Apply KCL at node P. There are 4 currents associated with node P. These 4 currents are I1, I2, I3 and I4. Out of these 4 currents, there is only one incoming current and there are 3 outgoing currents. I1, I2 and I3 are the 3 outgoing currents, while I4 is the lone incoming current. Therefore, according to KCL, we can write I1 plus I2 plus I3 is equal to I4. I1 is equal to Vp divided by 100, I2 is equal to Vp minus Vq divided by 50, and I3 is equal to Vp minus Vs divided by 20. Applying KCL at node P. I1 plus I2 plus I3 is equal to I4. Vp by 100 plus Vp minus Vq the whole divided by 50 plus Vp minus Vs the whole divided by 20 is equal to 4. So taking LCM as 100, Vp plus 2Vp minus 2Vq plus 5Vp minus 5Vs the whole divided by 100 is equal to 4. So 8Vp minus 2Vq minus 5Vs is equal to 400, equation number 1. Now apply KCL at node Q. There are 5 currents associated with node Q. There are 3 incoming currents and 2 outgoing currents. I2, I5 and I7 are the 3 incoming currents, while I4 and I6 are the 2 outgoing currents. So according to KCL, we can write I2 plus I5 plus I7 is equal to I4 plus I6. I2 is equal to Vp minus Vq divided by 50. I4 is equal to 4 ampere. I5 is equal to 10 ampere. I6 is equal to Vq minus Vs divided by 40. And I7 is equal to 2 ampere. According to KCL, I2 plus I5 plus I7 is equal to I4 plus I6. So Vp minus Vq divided by 50 plus 10 plus 2 is equal to 4 plus Vq minus Vs the whole divided by 40. So rearranging the terms, we will get Vp minus Vq the whole divided by 50 minus inside bracket Vq minus Vs the whole divided by 40 is equal to 4 minus 10 minus 2. So 4Vp minus 4Vq minus 5Vq plus 5Vs the whole divided by 200 is equal to minus 8. So rearranging the terms, we can write 4Vp minus 9Vq plus 5Vs is equal to minus 1600, equation number 2. Apply KCL at node S. There are 4 currents associated with node S, 2 incoming currents and 2 outgoing currents. I6 and I3 are the 2 incoming currents, while I7 and I8 are the 2 outgoing currents. So according to KCL, we can write I7 plus I8 is equal to I3 plus I6. I3 is equal to Vp minus Vs divided by 20. I6 is equal to Vq minus Vs divided by 40. I7 is equal to 2 ampere and I8 is equal to Vs divided by 25. According to KCL, I7 plus I8 is equal to I3 plus I6. Therefore, we can write Vp minus Vs the whole divided by 20 plus Vq minus Vs the whole divided by 40 is equal to 2 plus Vs divided by 25. Rearranging the terms, we can write Vp minus Vs the whole divided by 20 plus Vq minus Vs the whole divided by 40 minus Vs by 25 is equal to 2. So taking LCM as 200, 10 Vp minus 10 Vs plus 5 Vq minus 5 Vs minus 8 Vs the whole divided by 200 is equal to 2. So we have 3 equations. 8 Vp minus 2 Vq minus 5 Vs is equal to 400, equation number 1. 4 Vp minus 9 Vq plus 5 Vs is equal to minus 1600, equation number 2. 10 Vp plus 5 Vq minus 23 Vs is equal to 400, equation number 3. In matrix form, these equations can be written as matrix of 8 minus 2 minus 5, 4 minus 9 5, 10 5 minus 23 into matrix of Vp Vq Vs is equal to matrix of 400 minus 1600 400. According to Cramer's rule, we can write Vp is equal to delta 1 by delta, Vq is equal to delta 2 by delta, and Vs is equal to delta 3 by delta, where delta is equal to determinant of 8 minus 2 minus 5, 4 minus 9 5, 10 5 minus 23. Delta 1 is equal to determinant of 400 minus 2 minus 5, minus 1600 minus 9 5, 400 5 minus 23. Delta 2 is equal to determinant of 8 400 minus 5, 4 minus 1605, 10 400 minus 23, and delta 3 is equal to determinant of 8 minus 2 400, 4 minus 9 minus 1600, 10 5 400. So we will get delta is equal to 622 and delta 2 is equal to 2,47,200. So VQ is equal to delta 2 divided by delta, that is equal to 2,47,200 the whole divided by 622. We will get VQ is equal to 397.42 volt. So here we are asked to find voltage drop across 10 ampere current source, that is Vx. So Vx is equal to Vq. So Vx is equal to 397.42 volt. Thanks for watching Circuits Analytica. Enjoy learning.